Hello, all, and welcome to another fun episode of Statistics. Today I'm going to be talking about correlation and linear regression. This is the beginning of Chapter 4 in our textbook for Stat 1. So, just to get us all started off on what we're doing today is what we're really trying to do is ask ourselves, when I look at two quantitative variables, can I tell if they're related? And can I describe that relationship well? And how much of a relationship do I see? So, really, we call establishing this relationship association. And one of the numerical ways you can measure association is using something called linear correlation, also just called correlation or Pearson correlation. Now, this specific type of correlation, and there are many, is dedicated to just looking at how linearly related two variables are, or do they fit a straight line relationship. So, when you think about correlation, we want to establish two things. Well, how do I want to say this? I really want to talk about how they're related to each other and whether or not that relationship is strong and what the direction of that relationship is. So I've got some data here that I already put into a graph for you. So here I'm looking at 10 random vehicles, their length and their weight, and you should expect there to be a relationship here because usually larger vehicles are heavier in general. So you already walk into this with some suspicion that this is true. However, since we are all scientists, we need to, rather than just go with suspicion, look for facts and evidence. So as you graph this data using what's called a scatterplot is just a graph of any two quantitative variables, you'll notice that it appears that, and I added a line here, they have a fairly linear relationship. Now, we've got a couple points that don't fall into this straight line exactly, but it generally follows a linear pattern. And the first thing we want to notice about this linear pattern is we would call this positive. So positive correlation is going to go along with positive slope, negative correlation is going to go along with negative slope. And when you think positive, I want you to think about how it should be. And when you think negative, I want you to think opposites. So in general, when I see a negative relationship, I want to think about my variables do the opposite of each other. So that means that if one of them is increasing, the other should respond by decreasing. They behave opposite of each other. Or if one is decreasing, the other should increase. When it comes to positive correlation, they do the same thing. So if one is increasing, the other will increase. And then if the other is decreasing, then they're both decreasing. So they behave the same way versus they behave opposite of each other. And this is generally what that shape looks like. And we're going to go along with the idea of, we're trying to measure linear relationship only. There are other shapes, but we will not be doing them. We're going to look to try to make this match a line. So I'm hoping you remember some of your algebra from back in the day, whenever that day may have been for you. And that we are going to be using, the equation of a line, which you may recognize here. This is the algebra form, y equals mx plus b. We will be using the statistics form, which looks a little bit different if you're following along in your book. So, what we want to ask ourselves is, what type of relationship do I see? And do I suspect it, will be linear? And do I suspect that it will be positive or negative? So be thinking negative means they behave the same way, and positive means they behave the same way. Negative, they'll behave oppositely. So the first thing variable pair we're going to look at is temperature outside and amount of sales in an ice cream shop. Do I think this will be linear? I suspect it possibly could be linear, so I'm going to go ahead and say yes to that first one. I'm just going to take this and give it a little highlighting. And then if I ask myself, do I think it's going to be a positive or negative relationship? Well, if temperature outside was increasing and be getting hotter, when it gets hot, people tend to want ice cream like summertime. So I suspect that since these two appear to be doing the same thing, that this would be a positive relationship. All right. Square footage of home and cost to heat the home during the winter. I don't know about you guys if you've ever paid a heating bill, but if you think about a larger property versus a smaller property, usually you're covering more square footage and therefore more cubic feet of heat. And then you will usually end up having to spend more money on heat. So it appears that these two have a positive relationship with each other because they appear to be doing the same thing. When one increases, the other increases. And I'm going to go ahead and say that I suspect this is linear. I have a feeling that this tops off eventually. There's only so much this could happen, but we'll go ahead and do that. This one I love. A student's height and their grade and their statistics scores. So you got to ask yourself, do I think that taller people will have better grades? Or do I think that people, as they decrease in height, so as you get shorter, you'll have a better grade? Because that would be a negative relationship. I mean, it appears to me that these shouldn't be related at all because I don't know anything about tall people being correlated to how well they do in stats. So I'm going to go with no. And since I think there's no relationship here that's linear or any correlation or association at all, I will not mark this as positive or negative. So I'm going to call that done. All right. Number of hours a student studies for a test and their test score. So this is an interesting relationship if you've ever looked at it. I prefer quality over quantity myself, but I suspect that this possibly has a linear relationship. I mean, after a while, maybe studying doesn't do you any good because you're just rereading the same things over and over again, but I'm going to go ahead and say this is positive because I want it to be. And I think that's what motivates most people to study in general. Um, and then you ask yourself, oh, if I study more, I should do better. So this appears to be like increase, increase. So these behave the same way. I would call this positive. All right. Next up, let's look at number of hours a student spends watching TV and their GPA. Now, as you look at this, you've usually, if you're spending more time watching TV, you're spending less time studying. So, although I'm going to go ahead and say these are probably a linear relationship, it might not be. Um, just so you know. But increase in TV watching is probably going to decrease your GPA. These do the opposite, so I would say that this has a negative relationship overall. Weight of a vehicle and gas mileage of the vehicle. This generally starts to taper off after a while, but I'm going to go ahead and call it linear for now. And you know that as I increase in weight, my gas mileage tends to go down since these are doing opposites from each other. This is going to be a negative relationship. All right. This is where things get a little bit harder. So again, we're trying to establish association. There are several different parts to association. We look at strength, direction, and we also decide, does it look like it has a linear shape? So we're looking for a couple different things. So as I look at this first one, I look at the shape and ask myself, does it look like a straight line? Yes, it does. But it also looks like it doesn't keep quite on a straight line. You notice that we've got some spread. And so when I talk about strong, moderate, or weak, I really am trying to measure how spread out is this from the shape that I'm seeing. So I look at this, and this looks pretty strong to me. If some of you called this moderate, that's fine too, because it's not the greatest. But I would call this a strong because it's pretty easy right away to see the shape. Do I think this looks linear? Heck yes, I do. It's so linear lookings. All right, and it also looks like a positive relationship because as I increase in age, it appears the wife age increases as well. This is always a weird data set to look at if you were wondering. All right, I've also seen this in different states look like a curve, which is also interesting. Anyway, so check this guy out. I didn't even give you variables. Oh my gosh, it looks like a sneeze. Do you see any shape at all? Nope. I agree. It's like, this doesn't look like much of anything. So I'm going to say this doesn't look linear because I don't see any shapes here. Does it, if yes, strong? I mean, if you really wanted to, you could still answer this question. This looks pretty weak to me. Come on, just like that word. Okay, good. Positive or negative, that's impossible to answer because it doesn't look linear. But this is weak. This is what you expect from a weak relationship overall because it appears it looks kind of like a sneeze. Anyway. Aha, more non-variable nonsense. Let's look at this bottom guy. Or this isn't the bottom. Let's look at this guy, number C. Wow, I sound smart today. This looks kind of like a cylinder. Looks pretty straight. I would call this linear. This is not as strong as our previous relationship, so I'm going to go ahead and call this moderate. It's also sloping the opposite direction, and this is the negative relationship because I increase in one variable, I decrease in the other. All right, and so that's what I'm seeing here. Does this look like a linear shape? No, it does not. It still looks pretty strong, I would say. It's just keep a note here that this is not a linear relationship. Positive or negative, can't really tell because, well, as you see this, there's no real slope to it. It's clearly an arc, which we would call a quadratic relationship. Alrighty. So, next up we have height and calculated D constant volume. This I do believe is tree diameter and height. Anyway, don't worry about it. It's got a slight curve to it. It's not huge. I could say that this is very, very linear. And I'd say this is the strongest relationship we've seen yet. It's like super, super strong. This is the Superman of trees. Sorry, Superman of scatterplots. I need to be quiet. It's also quite clear that as you look at this graph, as I increase in height, I appear to be decreasing in diameter. This must not be trees. What was this? Oh, well, it's fine. Yeah, so this appears to be a negative relationship. Way to go with the tree comment. Oh, I didn't use the tree data. Memory. Okay. ARM versus Sims. I don't remember what this one is either. Oh, I stole this one from the internet. Go find this one. Should be a fun time. Actually, don't waste your time. It's fun. This looks relatively linear. It's a weaker relationship than what we've seen so far. So weak, I would actually call this one weak because it's pretty spread. So my scatter is so far from the shape that it's a little bit hard to see the shape, and you might suspect that it's got like a little dip right here. And so we would say this is a weak relationship. That being said, it appears to be a positive weak relationship despite its linear shape. So really what I want you to get across from this video is when we're considering linear correlation and the relationship between variables, specifically two quadratic ones, we can use correlation to determine, hey, how strong does this look? In our next couple videos, I'm going to go through how to actually calculate a numerical equivalent of this. So this is just sort of a visual verbal way of going through this, which I'm hoping you recognize is not good enough. You should look at this and be like, okay, this is stats. Where's the numbers, yo? How good of a line is this? And how can I measure that? That's totally what's coming next. Good predictions. See you next time.